Hello everyone, it's been a while. In this video, I will be showing how to install a gaming Windows virtual machine on Linux. I am using an Intel Core i5-10600K processor, a MSI B460M PRO-VDH Wi-Fi motherboard, and a NVIDIA GeForce GTX 1060 graphics card. The software I am using are all free except for the Windows 10 license. I am using CentOS 8. For the virtualization software, I am using KVM, QEMU, and Virt-Manager. I think that I need to first give the reason why I undertook this humongous project. The short answer is, I feel like Windows 10 has progressively gotten worse over the years. First, it was the updates they were coming out with that were breaking people's computers. Then, they started disabling people's ability to delay or forego installing these updates. Finally, with the newer updates, it seems to me that Windows is trying more and more aggressively to collect more and more user data. Simultaneously, they are installing more and more bloatware that the user can't uninstall. However, Windows had one thing that I couldn't get off of, and that was gaming. So this is my dilemma. I didn't like Windows, but I needed it to play games on. So if you're feeling frustrated with Windows but need it for gaming and need high levels of performance, then this may be the kind of setup you should look into. This is what my setup looks like. I have one computer. Inside, it has a CPU with integrated graphics and a discrete graphics card. The host operating system, the operating system that runs natively on the computer, is CentOS 8. I allocate one CPU core to it out of the 6 that the CPU comes with. In addition, it uses the integrated graphics on the CPU. Windows, the guest operating system, runs in the VM on top of the host operating system. I allocate 2 CPU cores to it. I also pass the discrete graphics card to it for its sole use. To this computer, I connect one keyboard and one mouse. Both the host and guest operating systems share these things together. I use a 4K TV as my monitor. I connect 2 HDMI cables to 2 of its HDMI ports. With one cable, I connect the other end to the integrated graphics HDMI output on the motherboard. With the other cable, I connect the other end to the graphics card. I then connect my speakers to the TV. This is a general schematic of what my setup looks like. Now here are the requirements you must have to be able to succeed with this type of setup. You need a CPU and a motherboard that both support virtualization and allow it to be enabled. The motherboard also needs to support IOMMU or Passthrough, and it needs to be implemented correctly. Some motherboards don't implement it correctly. This is not easy to figure out from the specs alone. Finally, you need 2 GPUs. I am using a CPU with an integrated GPU and a graphics card, but another option could be to use a CPU with no integrated GPU and 2 graphics cards. It's interesting to note that Intel CPUs all come with integrated GPUs. Now let's get started. The first thing to do is to build the computer. I won't get into that here, there's plenty of guides online. The next thing is to install CentOS onto the computer. This is a Linux distribution that was made by Red Hat. It's known for being stable and compatible with a large variety of hardware. If you're a beginner to Linux, then you may need to go with Ubuntu. Assuming you're able to get CentOS installed, the next step is to install Virt-Manager. So open GNOME software and search for Virt-Manager. Install that. Next, obtain your copy of Windows 10, either online or in store. I downloaded the Windows 10 DVD as an ISO file from Microsoft for free. Then you need to download the virt.io drivers. This comes in an ISO file that you can find in the Fedora project's documentation. I'll provide a link to it in the description. Next, we need to set some settings in the BIOS. Restart the computer and go into the BIOS. Here we need to hunt for the setting to enable virtualization. There's 2 of them that need to be enabled. On my motherboard, it's hidden away in the OC section. This next step is important. While still in the BIOS, be sure to set the primary graphics device to the integrated graphics, or IGP. I'll link to an article explaining it in more detail in the description. Once these are all set, we are done with the BIOS. Save it and exit. Boot back into CentOS. Now we need to change some things in the host operating system. Basically, we need to mark some CPU cores and the graphics card as off limits to the host operating system. You should log in as a super user or a user with admin privileges, like root. Open up a terminal. For the CPU, run this command. Each line here is a CPU core. Each number in each line is the thread number. Because the 10600K has hyperthreading, each CPU core has 2 threads. I only want the host operating system running on the first core. You don't necessarily need to have the host operating system running on only one core, so you can adjust accordingly. Now we edit grub by running this command. Add this section to the end of grub.cfg line Linux. This would be the same list of threads from earlier. Save the file with vi enter :wq. Now update grub by running this command. These command line arguments may be different if you're using a AMD CPU or graphics card. Next, it's time to identify the graphics card. Run lspci-nn. Find your graphics card. Here there's 2 entries and they both have NVIDIA in them. This is because with HDMI there's both video and audio. We need to pass these both through. Note the string near the end of both of these entries. Save these somewhere. Now we need to tell the operating system to use the VFIO PCI driver for these 2 parts of the graphics card. We do that by running these 2 commands. With that, restart the computer and go back into CentOS. Now we will check whether we have everything configured by running these 2 commands. If you see IOMMU enabled and the 2 devices being added using VFIO PCI, then we're good to go. Now it's time to create the VM. To do that, run Virtual Machine Manager or Virt-Manager. Then click on the top left icon to create a new VM. Choose to install using a local install media. Select the Windows 10 DVD ISO file. After you select the ISO, it should say Microsoft Windows 10. Leave the memory and CPU as is. We're going to customize them anyways later. Set the disk image for the virtual machine to be the size you think the VM will need for all the programs you will install onto it. Make sure that the Customize Configuration Before Install checkbox is checked. This is crucial. Now click Finish. Under Overview, make sure the Q35 chipset is selected and the UEFI firmware is selected, as opposed to BIOS. Click Apply. Under the Memory section, set it to be a reasonable amount that you think Windows will need to run your programs with. Click Apply. Now switch over to the XML view. Here we're going to set a few fields. First, put XML NS QEMU between domain and type. I find that if you put this after type, the settings aren't saved. Next, inside the CPU tune section, set the vCPU placement as static and use vCPU pin to pin the CPU threads that were marked off limits to the host operating system. Here I am allocating 2 of the CPU cores and setting their thread numbers, 4, 10, and 5, 11. Now under Hyper-V, set the vendor ID state to on and set any value for the value. It doesn't matter as long as it's not blank. If NVIDIA detects that you're running a VM, it will disable the GeForce graphics card from running. To trick NVIDIA, we need to set the vendor ID. We also need to set hidden state to on in the KVM section. We also need to set the IO APIC driver to KVM. Next, specify the CPU section. Set mode to host pass-through and set the topology. Host pass-through means that the CPU core will run the commands from the VM directly, without any translation overhead. What you set for the topology requires some in-depth knowledge. Now set the QEMU command line section. This is a copy and paste from a wiki that I'll link to in the description. After all this, click Apply. Then double check that all the settings were retained. Now I go down the list and remove tablet. I add a SATA CD-ROM with the Virt.io driver ISO file. Now I add the video card components, both the graphics and the sound. I click Add Hardware and select PCI host device. Then I select the NVIDIA graphics card. I click Finish. Then I do the same for the NVIDIA audio. Now that everything looks good, it's the moment of truth. Click Begin Installation. At this point, you should see a screen like this. Press any key. Now, toggle the monitor to the HDMI input from the graphics card. If it's working correctly, you should see something like this. If you see this, then keep going. However, if you see a blank screen or no input, you need to go back and check that everything was set correctly, beginning with the BIOS option for the primary graphics. Make sure it isn't set to use the discrete graphics card. Continuing on, toggle the monitor input back to the host operating system and install Windows as you would normally. Once Windows is installed, boot into it. The NVIDIA graphics driver should install automatically, but it may take some time, then reboot. At this point, if everything works successfully, then awesome. Open up Device Manager and check that the discrete graphics card was detected and installed correctly with no issues. However, if you get a blue screen of death, then it may be that the BIOS option for the primary graphics was set incorrectly, or that the XML configuration didn't contain everything correctly. You can review the XML by pressing the left control and alt keys simultaneously to release the mouse, and then click on the light bulb icon. Then click XML. The other common thing you may see is code 43. This would happen if the XML configuration is missing something and NVIDIA detects you're running a VM. Now then, go into the Virt.io CD, which should be there, and run the setup. Don't bother running the setup for the guest tools, as then the mouse will no longer be captured by the VM, as I demonstrate here. Now that everything works, I switched the monitor back to the guest operating system and install a few games to test out the performance. Here is Oxygen not included, running in windowed mode. You can see the task manager at the top. The CPU usage is a bit high. The NVIDIA graphics card is firstly being utilized, and as you can see, it's breezing through without much sweat. Now I'm playing a game of Heroes of the Storm while still running Oxygen not included. Here you can see that the graphics card is still able to handle everything without lagging or stuttering. So the performance on a dated graphics card playing dated games is more than enough for me using this setup. So mission accomplished. However, there's more benefits to this setup than just the convenience of being able to play Windows games and not having to interrupt my work. VMs provide a sandbox environment. This is beneficial when browsing the internet. I don't even browse the internet on my host operating system. Instead, I create a Linux VM dedicated to browsing the internet. I create another Linux VM for paying my bills online. These are just a few examples of some of these use cases. I get a VM set up the way I want, then I clone it and put the original away for future cloning. Then I use the clone for a year. After a year, I'll just delete the cloned VM and make a new clone. That way, if there were any malware that infects the operating system on the VM, I could get rid of it with relative ease and start over with a clean plate. I hope you enjoyed this video. If you have any questions or comments, just leave them below. Thanks for watching.